Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Kylo Ren by Melashenkos. And here are the rules. Well, we have a nice little cross lightsaber there in the shade of Kylo Ren's lightsaber. We have deconstruction, where within the 11 by 11 grid, there exist 9 non-overlapping 3 by 3 square regions, which must be located by the solver. Each region contains the digits 1 through 9 such that no digit repeats in any row, column, or 3 by 3 region. Cells outside these regions do not contain digits, but have a value of 0. We have also Kylo Renband lines, where values on a purple Kylo Renband line must be a set of consecutive non-repeating values. The values may be in any order, though, and we need to treat intersecting lines as a single Kylo Renband line, and that would be this. So this has to be a single Kylo Renband line here. Interesting. So that's an example of Kylo Renband. So for deconstruction, we have to construct 9 3 by 3 regions. So it could be something like this, 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 oops, this. This is just an example, right? So it could be something like this. And here, and then here, and then here. And this would be a valid example of the deconstructing really, 9 3 by 3 regions out of the 11 by 11 grid. And you would have to fill each of these regions with the digits 1 through 9 without repeats in any row, column, or designated regions. And cells outside the region do not contain digits, but have a value of 0. Okay. Again, Kylo Renband lines, they are essentially Renband lines, but they must have any lines that cross are in the same Kylo Renband line. So, for example, this could be the digits 2, 3, and 4 in any order, or it could be 5, 6, 7, and 5, or something along those lines, etc., etc. And then we have killer cages, where values in a cage must sum to the total in the upper left-hand corner of the cage. Non-zero values may not repeat in a cage. So 0 values can repeat in a cage, obviously, but non-zero values cannot repeat within a cage. So let's say this was actually the cages or the regions that we actually deduced was correct. Then if this were, say, a 3, this would have to be a 6, because these two digits in this cage must add up to 9, because these are 0, right? And they cannot have duplicates. So that's an example of how killer cages work. And finally, we have thermometers, where values along a thermometer must increase from the bulb end. So as an example, you could have something like 4, 5, and 7 here, and that would be valid because it's continuously increasing from the bulb to the tip. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, on a Renban line, you can only have 1 0 at most. Also, let's look at the cages. In these cages, particularly this one, you can only have either one digit be in that cage, be valid. You could have two digits being valid in that cage. You cannot have three, though. So what are the possibilities for regions that would fit this cage? For a 3 cage, it's the same thing. You have to have one digit or two digits. It can never be 3 or 4 because of the way that deconstruction rule sets work. And these cannot both be 0. So this, for the 3 here, these cannot both be 0. And because of that, one of these must be in a region, at least. It could go one this way, and then one this way. But one of them at least has to have... Oh. This cannot be a single digit. If this included a 3 here, this would have to be 1, 2, 3 as the Renban values. But it's not possible. So this has to be 0 with 1 or 2 here. And it could be a 1, 2 pair. Or, and if this is 1, 2, I guess this could be 3 here. If this is 0, 1 or 0, 2, this has to be 1 or 2. And if it's 0, 1, 2, again, this could be 0. So we're guaranteed 2 digits in this box have to be the ones that are filled. Because one of these is 1 or 2. And that means one of these has to be 1 or 2. Or both of these could be 1 or 2, right? Interesting. These are all on Renban lines. Again, we can't have repeats, but we can have up to 4 zeros. Right? This is 1, 2, 3, 4. But we are guaranteed... Okay. So we only have 4 zeros at most here. Right? The problem with that is to actually form a real deconstruction region, you have to either have sets of 3 digits, 6 digits, or 9 digits in each column or row, right? Because of the way that the shape is, right? So because of that, this is guaranteed then to have at least 7 because there have to be differing digits on each Renban. So this is 3 delete. This is a 0 at 1 0 at most here with 3 other digits here. This could be 0 and 1 as another digit. Oh, wait, that doesn't even work. You can't have that many zeros, period. Right? Because this would be 0 and 1. This would be 0, 1, or whatever. I guess this could be a 0. So on this, okay, that makes sense. In column, which one is this? 8? Yeah, column 8. These Renbans have to have values which are consecutive. There can only be 1, 1 in this column, which means there can only be one Renban here which can be consecutive with a 0. But this could be 0 by itself. And if this is 0 and 1, the rest of these ren bands can actually work. So this has to be a 0 here. This must be some 0, 1 pair. And these have to be the digits 2, 3, 4, 5, or 6, 7, 8, 9. Interest. How does that work? I don't think that works, does it? Oh, no. Yeah, that doesn't work. This cannot be 0, 1. If this were 0, 1, the problem is that this still has to be 0. So this can't be 0 here. This becomes a 1, 2 pair on this ren band. But the problem is, yeah, this can't be, well, this digit has to be, cannot be 0. It's 1 or 2 here. So these are both valid cells. Because of that, these 3 cells must be in a region, right? Because of the way that the squares are formed. Since this is not 0, because it can't be 0 because of the 0. Actually, I guess this could be 0. It just can't be 1 or 2. It can't be more than 1 or 2. So this could be 0. Interesting. That means this must be 0, 1, 2, or 3 here as the ren band. And this must be, cannot be 2 or 3 in the rest of the column. So this has to be 4, 5, 6, 7, 8, 9. And this is either 4, 5, and this is 6, 7, 8, 9. Or this is 8, 9, and this is 4, 5, 6, 7. So this can't be 6 or 7 here. Therefore, these are all part of a region. We don't know which. And this is one, and these two are part of a region. We don't know which. Okay. If this were part of a middle region here, I guess it could just be here, though. That's fine. So this is definitely part of a region. We'll make that pink. It cannot be part of this orange region here. That means this must be 3 cells that way as a region. This could be a full region here. This still could be a region that way. The problem with this being a region, though, I guess it's possible. You could have 1, 2 here, and then these add up to 13. That is possible. But then this would have to guarantee... Okay, so that wouldn't work. So because... Okay, so say this was a full region there. The problem with that is this would have to be 0 in value, so this would be 1 and 2. Well, this couldn't be 0 and 1 because this can't be 1. So this would have to be a full region, but then this would be 4 unique digits adding up to 9, which is not possible. So this actually then cannot be the same region as what contains this. Because if it were, we try to have it there. This becomes 0, 1, 2. This can't be 1. So this can't be 0, which means this is a full region, which means this doesn't work, right? Because this has to be part of a region. It can't be part of this one. So it must be part of its own separate one. And then this would add up to 10. So this, we're going to make that medium gray. It can be either this one. It cannot be here as a region. So we know this dark region is these 4, and it must be either this one. Okay, so it cannot be this. It could be this one, because then this doesn't have to be 1, 0, 1, 2. So that could be 0. Okay. Uh, this cannot be a region by itself because then there can be no 3 by 3 square which can be part of this cage. So this is not allowed. It could be the full here. That's possible. What it cannot be is this as a cage, right? Because if it tried to do this as a cage, then this would be 0 and 0, and that's not allowed. So this cannot be part of the cage for the 2, and we need 2 digits here. It can't be 4 digits. So this has to be essentially part of the orange. So this is a cage by itself. So that's done. Then this has to be a region here because this gray region cannot go any further this way. This has to be dark as a region there. So then this is 0, which forces this to be a 1. This is a full medium gray region. Orange we already have. Uh, hmm. So we need to have a 1 in this orange region. So 1 has to be one of these digits here. These are consecutive. These could be just 2 digits here. And 7 and 8. That's possible. It could be 3 digits even. We know one of these two must be part of a region. Okay, so this cannot be part of a region if this is not part of that region too. Right? You can't I guess you could have... It's possible. Hmm. Um... Hmm. So this cannot be 0 here because these are definitely part of a region. The blue is not part of this pink region. The rest, well, we don't know. This can't be 1 or 2, though. So this is 3, 4, 5, 6, 7, 8, 9. Because this 1-2 pair must be different than each other. Because they're on a run band. There are no repeats. If we have a region here. So these two always have to have values, right? Hmm. So these 2 digits add up to 9. Can't be 1. Can't be 1. 8. So 2, 7, 3, 6, or 4, 5. Technically, it still could be 4, 5. Hmm. This is a border. This is also a border. Um, Oh, interesting. Say this was a separate region here. We know these 1s and 2s are different, so none of these could be 1 or 2. That means this would have to be 3 something, right? To be part of a region. So it would have to be at least 3, 4, and then this would be 5, 6 at least. So you'd have 3, 4, 5, 6, which adds up to greater than 15. So this cannot be a full region by itself. So either this is part of the pink or this is empty. Either way, there has to be something here. Again, this can't be, well, I guess it could be part of, oh no, that would be a full region here. So if this were not part of the pink region, it would have to be either here or here as a region, and this can't be a full 4-cell region. So this must be part of the pink region. So this is pink, which means one of these are a pink set. And it either goes up here or it goes down here. If it goes up here, this has to be a 3, and the rest of the cell has to be 0. Is that possible? I guess? Otherwise, this is empty. This could be a 3 by itself. It could be all of these. That also works. Hmm. How long is this red band? We have 1, 2, 3, 4, 5, 6 on this red band. So 4. It could be 0, 1. Okay. So this is guaranteed to be 0, 1, 2, or 3. Which means if it's 0, we have 4. We have 1, 0, 1, 2, 3, 4, and 5. If it's 3, it could be 3, 4, 5, 6, 7, and 8. So this is guaranteed to be 0 through 8 without a 4. Okay, this 4 eliminates 4 here and 4 here. So this can't be 4 and 5 adding up to 9. Oh, these two have to be the same region, right? This is guaranteed to be a cell in the region, because every other cells outside regions do not contain digits, so this must be a digit. And it could be 1, 2, 3, or 1, 2, 3 here. Interesting. What happens if we have a green region here? This is then guaranteed to be 1 and 2. And this would have to be a region then. Right? Because this would be only 1 out of 1 or 2 along the Ren band. So the other 1 or 2 could not be in that region. So that would have to be a 1 or 2. Interesting. So the possible combinations for this 3 by 3 containing this green set are either here, here. Oh, it cannot be this, because then this would not have a region and this would have 0 digits. So that's not possible. It could be here. So this is possible as a region. Start in the upper left hand. How about this? You could do something like that. So that's potentially possible. Okay, so what happens if we have that? If we have that, and then we have that, it would have to be that way. And then these two would be both empty, and they'd be both 0 in value, which is not possible. So this is not possible here. What about here? Maybe? One of these could have to be a region. So this is okay. So this is possible as a start point. It cannot be here. What about this? So we had green here. That's possible. No, it's not possible. This would have to be guaranteed to be 0, and you can't have... You only have one 3x3 region left in the upper left-hand corner. And it would not be able to access all of these digits, so that would have to be 0, or this would have to be 0. And you'd have double zeros on this red band, which is not allowed. So this cannot be green. What about this? This could potentially work if this were the other region, right? So we know the top left corner of this region has to be these cells. This must be a full green region. So this is a boundary there. Yeah. Okay. Oof. This is a Renban. It could be the full amount, technically. Right? Ah. If this were a region, this region in the upper left corner would have to contain at least would have to contain 3 out of these 4 cells. So then it would be both of these with this one or both of these with that one. But the problem with both of these and that one is that this would not have any cells in a region. Oh, I guess this could go up here. That could be the case. So then we'd have a region there. So technically that could work if the pink were up here. So then this would be 3. This would be 0. So we'd have 1, 2, 3, 1, 2, 3, and 5 here. That's technically possible. Okay. So yeah, it still could be down here too. Okay. So any of these are still fine. Hmm. So this digit has to be, okay, 3, 4, 5, 6, 7, 8, 9, technically. Because you could have these digits here be part of a set. Hmm. Okay. We are guaranteed one of these digits must be non-zero. So that means this digit is non-zero, right? If this digit is non-zero, how does it form a 3x3 square without that being 0? And this must be greater than this, and these can never be 0. So both of these are in a region, guaranteed. That means, since both of these are in a region, it has to be these sets. We don't know if this is actually part of that region, so we're going to make that a yellow here. But this is guaranteed to be part of a region. So it's either here or here, which means this can never be part of a region. Same with this. This is part of a region. This is a part of a region. They could be part of the same region or different regions. This is a part of a region. Oh, interesting. Hmm. Yeah, that's fine. So this is valid part of a region. This is part of a region. We're not sure which. This is part of a region. It cannot be green, so this could be green or red. Since this is part of a region, this also must be part of a region. And how does this? Yeah, this then has to be all of these must be part of a region. Because since this is part of a region, what 3x3 boxes can it be part of? Here, 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 and here. Those are the only choices. So these are always going to be part of a region, which means this is a 1, 2, 3, 4 triplet. 4 cannot be here or here. This is smaller than this digit, so this must be a 4 here, which means this can't be 4. So this is 1, 2, 3 here. 0 could still be here because you can have, they're not actual digits there. We have a 1, 2, 3, 1, 2, 3 triplet in row 9, which eliminates 1, 2, 3 in the rest of the row. So that means this must be 4, 5, 6, 7, 8, 9. But it could be 4, 5, 6, 7, 5, 6, 7, 8, and 6, 7, 8, 9 there. Um, uh, okay. So this could be the blue region also. The blue region can be here, here, or here. We don't know which. Hmm. So this is 1, 2, 3, which means this has to be 0 through 6. 3, 4, 5, 6. Yes. This still could be 0 here. If this is 6, this would guarantee this is with at least a 4. This would be 3. This would have to be 6 and 4 if that's the case. So it cannot be 6 here at least, because that would guarantee this is a 4. Well, not necessarily. Yes, because it would have to be, these would all have to be digits. And then 6 and 4 plus 3 is at least 13, so that's not possible. So this cannot be 6. Can this be 5? 5 could be 2 and 4, so that's possible. 5, 2, 3, 4, or 5. Well, it can't be 5 and 3, because then that would be minimum 3, or minimum 4, and that would add up to 12. So this could be 5 here. You could still have, can you have 6 here? Yes, if that's 0. That's possible. This can't be 1, 2, or 3 because of the 1, 2, 3 triplet in the row. So this is either 0, 4, 5, or 6. That's interesting. If it's 4, 5, or 6, these are guaranteed to be digits. If it's 0, then these can't be 0. So these are guaranteed to be digits no matter what. Probably green. We don't know. Green or red. Actually, it has to be... This could be red. This cannot be red. So this must be green here. Which means green cannot be here. Green could still be down here. This could be light. Right? Or it could be blank. Hmm. If this is red and red, that would be 5 and 6 there, which is possible. Oh, this can't be 4 because of the 4 in the green region and the 4 in the red region. Well, technically, this could be yellow also. It cannot be pink because pink stops there. This is 3, 5, 6, 7, 8, 9. 3, 5, 6, 7, 8, 9. So this is either 4 or 5, 6, 7, 8, 9 here, or it's 0. That could be. Oh, no, it can't be 0. If this is 0, this has to be 3. So this has to be part of pink. So this is all part of pink. And this is done as a region. So this cannot be 0. This is at least 3 digits adding up to 15 with the minimum 4, 5, and 6. So this must be 4 and 5. This can't be 4, so this is 5, which makes this 4. This can't be 4, 5. So this must be 6, 7, 8, 9. And then this must be a 6, and this is a 5. 5 adds to, with this digit, to be a 6. So that eliminates, this can't be 4 and 5. It can't be 3 and 6. This has to be a 2, 7 pair. So if this is 7, this has to be 8. If this is 2, it can't be 1, it's 3. So if this is 2, this is 1 and 3. If this is 7, this has to be 8 and 9. So either this is 1 or 9 here. That means eliminates 5 and 6 in the rest of the pink region. So this must be 3, 4, 7, 8, 9. This cannot be 3. Sorry, this can only be 3 because of the cage. So this is 3, which means these can't be 3. This can't be 4 because of the 4 in the row. So this one of these two is a 4. That means this can't be 3. This has to be 0. The rest of these are 0. So this is not part of green. This has to be light, which means the rest of this ren band is 0, 1, 2, no 0, 1, 2, 3, and 5. This can't be 3 or 5. This can't be 5. So this has to be, well, we don't know if that's a region. Well, we do know. We have to have all of this as a region. So this is light as a region, therefore green has to go this way. So this is green. So that's done as a region. This is done as a region. We don't need the zeros anymore because we already know that. This is 1. This has to be 0. We have 1, 2, 3. This can't be 4 anymore because of the 4 in the region. Red has to be going down here. So these are red. And it goes either here or here. We're not sure which. This is at least 4. So this cannot be 6 and this can't be 6 at all because these two are both digits. This can't be 9 because there's at least 3 digits here. So as a ren band, either this is 0 with 1, 2, or 3 as possibilities. Or, well, this can't be 3 and 5. It could be 2 and 5. So what are the possibilities here then? 1, 2 works with 8. 1, 3 works with 7. And 2, 5 works with 4. So 1, 2 means this is 0 or 4. So 1, 2 means that's 3, and that's 4. 1, 3 means this is 0 or 4. That's 2. And 2, 5 it can never be 1, 2, 3, 5 here. So this is 0, guaranteed. This cannot be double yellows. So if the yellow goes here, this would be 3 digits here, which is not possible because you can't have 3 unique digits, or 3 digits add up to 3 with 2 of them being unique with each other. So this has to be a 0, which forces this to be 1 or 2. Oh no, it has to be this way. So then this is blue. Okay, so then this is blue. This is 1 or 2. This is 1, 2, or 3. This must be 0. So this is a region because, again, it cannot be that is a cell and this is a cell. And if this were a separate region, it would have to be that way. So this is 0. This must be 1, 2, 1, 2, 1, 2, 3, 0. This has to be 7, 8, 9 here. Because of the 6. This is 0. These are all 0, so those are done. If this is 2, 5, this has to be 4, and this is 3 guaranteed. Okay. If this is 1, 2, this is 3. So this is the same digit as this, I believe. Also, we have a 1, 2, 3 triplet in column 3, which eliminates 1, 2, 3 in the rest of the column. So this has to be 5 through 9. 5 through 9, 5 through 9. This is smaller than that, so this can't be 9, this can't be 5. This is smaller than that, so this can't be 9, this can't be 5. This can't be a 6 because of 6 in the row. We don't need these because these are clear. This can't be 0. This has to be 0, and this has to be 0. And there's no way, so the yellow one cannot be here. So the yellow has to be at least both of these two. And then it could be here or here. So this is done. This is done. Kind of. Okay, this cannot be 3. So this, if this were 1, 2, 3, this would have to be 1, that's 2, and this would be 3. So 3 in the orange box must be here, which means this can never be 3. Where is the 3 in column 3? It has to be one of these two cells. So this can never be a 3 here. Remaining digits in the blue region have to be 4 through 9. But these can't be 4 because of the 4 in the row. This can't be 7 because of the 7 in the column, the 2, 7 pair in the column. Therefore, where is the 4 in the blue region? Well, 4 could be here too. Oof. So either of these are 4. Okay. This one eliminates 1 here. Remaining digits in row 6 have to be 1, 2, 3, 7, 8, 9. But this is 1 or 2. If this is 1, that would force us to be 9, which would mean this cannot be 7, 8, 9, so this would have to be 2. If this is 2, this would be 7, which would force us to be 8, 9, which would make that 1. So either way, there's a 1 or 2 here. There's 1 or 2 here, and there's a 1 or 2 here, which means this cannot be 1 or 2. This is 3. This can't be 1, 2, or 3. It's 7, 8, or 9. That means since this is 3, this can never be 3, and this can never be 3. So this would be 0, 1, 2, 3, or 1, 2, 3, 4, or 4, 5, 2, 3. So either way, this is a 3, which means this cannot be 3 here. This can't be 3 here because of the 3 in the row. Where is the 3 on this red band? It must be here. So that's 3. We'll mark this as an A and this as B, which forces this to be A to add up to 3 because we don't have any repeats in a killer cage. Non-zero values. This is A, which forces this to be B. A then in the gray region must be one of these 3. That doesn't tell us much. B has to be one of these 2. A has to be one of those 2, which means this can't be A. This is B. Since this is B, this has to be A, which makes that B. So we got B here, A here. A can't be here. So this cannot be 1, 3, and 7, adding up to 11. This is B. This is a 1, 2, 5 triplet in the light gray region, which eliminates 1, 2, 5 in the rest of the region. This can't be 5. So this cell must be greater than that. It must be 8 or 9 here. Okay. The rest of this light region has to be 3, 4, 6, 7, 8, 9. 3 and 4 cannot be here. Where are the 3 and 4 in this region then? Can't be here. This has to be a 3, 4 pair, and this can't be 4 because of the 4 in the column. Therefore, that makes that 3, which makes this 4. Okay, that makes sense. So this is either 1, 2, 8 or 2, 5. So either way, this is guaranteed to be a 2. B cannot be here and B cannot be here. So B has to be one of these 2. And it cannot be here because of the B in the column. So this must be a B, which means this is not 5. It's 1 or 2. This is B. This is A. That's fine. A has to be one of these 2. We don't know which. So A must be one of these 3 digits here. That doesn't tell us very much. B is here in the red region. B is here in the blue region, which means in the yellow region, B has to be one of these. But it can't be here because B in the column, so B must be one of those 3. Cannot be here because of the B here, so one of these 2 must be B. Actually, B is here, cannot be here in column in the gray region, in the medium gray region. It can't be here, so it must be here. So B has to be one of these, therefore this can't be B. This has to be the B in the yellow region. What about A? Oh, well, this is either yellow or it's nothing. Red can never go here because if red's here, this has to be a 4 at minimum, or it has to be 0, which it can't be in the red region. So the red region has to go here. So this is done for the red region, which means the remaining digits in the red region are 5 through 9. 6 has to be one of these digits. Well, that's kind of given. Remaining digits in column 2 are 1, 2, 5, 6, 7, 8, 9. Okay. It's not too helpful. A cannot be either of these. So A has to be one of these two. So this cannot be 1 or 2 because of the 1-2 pair in the row. Let's see. A is one of those two. A's here. A has to be one of those two. Hmm. Okay. Let's look at this. Adding up to 16. You can't have 2 and 3. You could have 2 and 4 potentially. Okay. What are the remaining digits in column 10? They have to be 3, 4, 5, 6, 8, and 9. Okay. If this is 9, this is guaranteed to be at least a 7. And this is 9, 7, and 1 already for 3 digits, which adds up to 17, which is greater than the cage. So this cannot be 9. If this is 8, this is guaranteed to be at least a 6. So it'd be 1, 8, and 6, which adds up to 15, which with a 2, which is the minimum amount possible, would add up to 17. So this cannot be 8. So this could be 3, 4. Oh. No, we don't know. This could be 3, 4, 5, 6 as possibilities. In column 9, we are guaranteed a 9 in the orange region. So since this is 9, that eliminates 9 from the rest of the column. So this can't be 9, and this can't be 9. Where is the 9 in the blue region? It must be one of these two cells. And this cell must be less than that, so this can't be 8. This cell is less than that, so it can't be 6 or 7. So it's 4, 5, less than 5 is 6. And 9 is one of these two, which means this can't be 9. Remaining digits in the medium gray region are 1 through 6, and this can't be 5 or 6 here, so this must be a B and a 5, 6 pair here, which means this is 1, 2 with 5 or 6. This must be 3 or 4. This can't be 1 or 3 because of the 1 or 3 in the row. So this is 2 or 4. This can't be 1 because of the 1 in the row. Again, this cannot be 6 and 8 because 6 and 8 adds up with 1 and 2 to add up to 17, which is greater than the cage here. So this could be 7. It could be 2, 4, 5, 6, 7. So this is at most an 8 here. So this is 2 through 8. This can never be a 9. So can this actually ever be 2 here? I think the answer to that is no. Right? If it's 2, this is 4 at most, and this would require a 9 here, but we can't have a 9 because of a 9 in the column. So this can't be 2. At least here. A is one of these 3. It's not so helpful. Okay. If this is 2, this could be 3, 4, and 8. That is possible. This can be any digit from 2 through 8. Yeah. It just can't be 9. Oh, and in fact, where is the 2 in this region? Or actually, where's the 2 in column 9? Cannot be here, cannot be here. So it must be one of these 2 digits here. So 2 is one of these, so this cannot be 2 then. Um, hmm. Still could be 3, 4, 5. That's possible, I guess. Ah, where is 7 in the blue region? 7 has to be one of these 2 digits because it can't be here because of the 2, 7 pair in the column. Therefore, that eliminates 7 in the rest of that column, so this can't be 7, which means 7 has to be one of these 3 digits. So this can never be 8 because 8 would have to have a 7 at least on it with a renban on it. We have a 2, 4, 5, 6 quadruplet in row 3, which eliminates 2, 4, 5, 6 in the rest of the row, so this must be 7, 8, or 9. Okay, we know 9 has to be one of these 3 digits. So 7's one of these 3 digits, 9's one of these 3 digits. Interesting. So this can no longer be 2, because 2 would have to be with 6 and 7 specifically on this renban, and it can't be there anymore because of the 7 in the column. So this can never be 2, which means where is the 2 in this region? It must be here. That eliminates 2 in the rest of the row. That's fine. Okay. Okay. These digits cannot be A or B because we have a B already in the region and an A in the column. So this must be 3, 4, 5, 6, 7, 8, 9. 3, 4 cannot be here. 3 cannot be here because of the 3 in the row. This can't be 1 or 2 because of the 1, 2 pair in the row. So it has to be 4, 5, 6, 7, 8, 9 there also. This could be 1 or 2. We don't know. Okay, what else do we have here? Can this ever be 8? If this is 3, 4, and that's 5, that's possible. And this is a 7, 9 pair. Hmm. Hmm. Interesting. Okay. Where is the 3 in the yellow region? Oh. Yeah, where's the 3 in the yellow region? Can't be here, any of these. Can't be any of these because of the 3's in the row. Can't be here because of the 3 in the column. Can't be here because of the 3 in the column. Can't be here because this is guaranteed to be 3 there. So it must be here. So that's a 3. That's interesting. Hmm. A cannot be any of these cells because A is guaranteed in that column, so A has to be one of these three cells. We don't know which. Ugh. Let's see. Uh, if this is 765, then this would be 4. That does work. This can't be 9 here. Hmm. We have a guaranteed 5 and 6 here, so this cannot be 5 or 6. Oh, interesting. Hmm. Huh. Okay, so if this is 2, 5, this has to be a 4, right? So 2, 5, which would make that 1. This would be 4. This would have to be 4. That would make this 5, 6, and we don't know what, 7 or 8. So this would have to be yellow. 4 obviously could not be either of these. This could not be 5 or 6. This cannot be 5 or 6. We'd have to have 5 could not be here, so 5 would have to be here, which would make that a 1, 2, 6 triplet. Cannot be 2, so this 1, 6 triplet, or pair, which makes this a 2. This is 2, this is 1. This is 2, this is 1, which makes that 2. This can't be 1 or 2, so it's 5, which makes that 2. That's a contradiction, because that would have to be 1, and that's not possible. So, we know this can't be 2 and 5. This has to be a 1, 2 pair. So this is A, which means this cannot be A. And it can't be 1 or 2 here. This is a 1, 2 pair. So this is A, and this is B. Okay, and therefore this is an 8. So since this is 8, none of these can be 8. This becomes a 4. So this cannot be 4 anymore. 8 can't be here. 8 has to be one of these two digits here. So 8 cannot be here in the rest of the row. Hmm. A cannot be either of these, so this must be an A here, which makes that 1, 2. Okay. Where? That would be 4. Okay. In the yellow region, if this is a region, then this must be, actually, this has to be a 4. If this is the yellow region, 4 cannot be here because one of these must be 4 for the gray region, and this has to be a 4. So either way, one of these is a 4, which eliminates 4 from the rest of the row. So this cannot be 4. This is 5, which makes that 6. This has to be a 4 then, because it can't be 4. They can't have 4, 5, and you can't have 4 in any other cell in that region. This can't be 6. This can't be 5 or 6. We have a 7, 8, 7, 8 pair in column 9, which eliminates 7, 8 in the rest of the column. This can't be 8. This can't be 8, so this can't be 7, 8, 9, which means this is 2, 1, 3 to be a Renban. And B has to be 2. Which means this, we can remove those B's and those A's. So this is not the B. This is not the A. So all the B's have to be 2. And all the A's have to be 1. So these are 1. This is 2 and 7. 7's consecutive with 8. This must be a 3. This is a 9. That eliminates 9 from that cell, so this is 7, which makes that 9. This can't be 7 or 9. It becomes a 6, 8 pair, which eliminates 6 and 8 in the rest of the region. So this must be 7 and 9 here. That eliminates 7 and 9 in the rest of the column. So this is 5, 6, or 8. That means 2 cannot be either of these. This must be a 4. So 4 cannot be either of these. That means this can't be 4 or 5, so that's 6. That eliminates 6 in the rest of the box, or the region. Yeah, the box. This can't be 6 either. Wait, we have a 1. That's not 1. This has to be a 5. That eliminates 5 in the rest of the row, so this is 2. This can't be 9 or 9 here. Where's the 9 in the dark region? It cannot be here because it can't be on the Renban with 6. So this must be 9 here, which means this can't be 9. So this must be a 9 here. This can't be 1 or 2 anymore. This can't be 2. Okay. This can't be 5 or 6 because of the 5 or 6 in the row. This can't be 5 or 6 because of 5 or 6 in the row. We have a 7, 8, 9 triplet, which eliminates 7, 8, 9 in the rest of row 10. So this can't be 7, 8, or 9. It's 5 or 6 here. This can't be 5 because of the 5 in the column, so this is 6, which means this can't be 5 or 6. This can't be 6 anymore here. And this 6 eliminates 6 here, so this must be 8, which makes this 6. That means this can't be 8 here. It's a 7, 9 pair, which eliminates 7, 9 in the rest of the region. So this is 5 or 8. These can't be 6 anymore. So 6 has to be one of these two. That's fine. This is a 7, 8 pair, so this can't be 7 or 8. It must be 9, which means this can't be 9 here. This digit cannot be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So this cannot be part of a region, so this must be part of a region then. And this is yellow. That makes this a 4 to be consecutive with 1, 2, 3. So this can't be 4 here. That leaves these digits as 5 and 6, and this can't be 6 because of the 6 in the row. So this is 5, which makes that 6. This is done as a region. This is done as a region. We have a 7, 9 pair in row 9, which eliminates 7, 9 in the rest of the row. So this can't be 7 or 9. It's 8, which makes this 7. That makes this 9, which makes this 7, which makes that 9. This 7 eliminates 7 here, so it's 8, which makes that 7. The remaining digit here is a 4. We have 1, 4, and 6, which adds up to 11, so this must be a 5. 5 and 6 are only on a Renban with 4 or 7, and this can't be 4, so this must be 7, which makes this 8. This 8 eliminates 8 here, so it's 7 and 8 there. This can't be 7 or 9, so this must be 8, which eliminates 8 in the rest of the regions, so this can't be 8. This is 6, which makes this 5, which makes this 8, which makes that 5. This can't be 5 or 8. It can't be 7, so this must be 9, which forces this to be 7. This 5 eliminates 5 here, so this is 6, which is 5. This can only be a 3, because that's the only digit remaining in the dark gray region, which makes this a 1, and this a 3. And we don't have a 0. And that's a solution. Yeah, pretty interesting. It's basically a typical deconstruction, chaos deconstruction rule set with just the Kylo Renban essentially line. I would consider this hard because this is a little bit more difficult than a typical deconstruction. Well, yeah, it's basically a typical. I feel like it's a typical deconstruction rule set Sudoku, and those tend to be hard in my opinion. But maybe that's just me. Interesting uses of the cages to restrict things, but yeah. Pretty cool stuff. Pretty cool stuff. Anyways, I hope you enjoyed this solve today, and I'll see you next time on Frank Puzzles. Take care.